Good afternoon. This is Liu Yanling. I'm going to present my progress updates on my research. The topic of my research is detecting the cyber attack using anomaly detection methods. The presentation is going to with introduction, including problem statement, database, background, and literature review. Then we come to the contributions, which are including the anomaly detections with matrix profile, anomaly detections with autoencoder, anomaly detection with booting methods. Then we come to the plan for the next week. So the problem I'm trying to solve is to build individual model to detect the cyber attack using BATADAO datasets. The technologies going to be used are matrix profile, autoencoder, and boosting. Then we'll combine the individual models to give an integrated cyber attack detection system. So in the for the following presentation, I will use battle to represent BATADAO datasets. So let's first look at what is the battle datasets. So this dataset is given by iTrust, which hosts world-class testbeds for experimentation. And the iTrust organized a competition battle to objectively compare the performance of algorithms for detection of cyber attacks in water distribution systems. So the data sets are shared in iTrust and the competition website. They are training data set 1, which contains 1 year simulated data and has no attack. Then the training data set 2, which is around 6 months and contains several data sets, several attacks. Then the third is the test data sets, has 3 months and contains several attacks. So for this data set, right, it has 43 variables in the network. So looking at the individual variables, we found there's 7 tanks water level and also 1 water flow from around a wall and 11 water flow around the pumps. And also it has stadiums of 1 valve and 11 pumps. And then it has 12 pressure. 1 is for valve, 11 is for pumps. The sample plots are in the next page. We can see start from top to bottom, left, and then left to right. We can see the tank level, then flow for pumping, then flow for valve, then stadiums of pumping, stadiums of valve, and then pressure. So now we have more background knowledge on the time series. So time series basically can be categorized into 2 classes, univariant and multivariant. So we can represent the time series using the equation in the screen. And also the time series can be break down into systematic and non-systematic components. So we can decompose the time series into seasonality, trend, and remand. Remand is basically the noise. Then the characteristic of the time series, right, can be retrieved by reduce the dimension of original signals. Like we can do the resampling of the original signals and do the PAA, the original signals. Then come to the anomaly detections. So anomaly detection, in another words, is outlier detections. It's trying to find the outliers which are outstanding, which has the outstanding values than others. So these outliers may represent abnormal behaviors. And we do, to categorize outliers, we categorize them into 3 types. One is global outlier, contextual outlier, and then the collective outliers based on the natures of these outlier points. And then we have a review on this anomaly detection methods. So anomaly detection can be supervised, unsupervised, and semi-supervised. Depends on how the labels of the data set. And then for the anomaly detection algorithms, we can using that purely statistically based, like Gaussian distributions, where we know like the really happened category, categories, right? And then also the distance based, which most commonly used are KNN model. So, and then the clustering based and also the classification based methods, mostly is like by classification based methods. We know that it's has a tag or doesn't have a tag. And then feature based. So we extract we extract the feature of the raw time series, then pass this feature to the other classification model to decide if there is a tag or not. Then it's a deep learning model, which is which there is a deep learning based autoencoder. And after we have detections, right, we have several statistics to evaluate the results. The accuracy, precision, recall, F1 score, and AUC. So for the equations for this statistic are in the screen. Now we come to have more details on the matrix profile. So for the matrix profile, right, it's only have one one hyperparameter, which is the length, which is the aim in the screen, right? So if I will elaborate it with the examples. So for example, right, if I define M as 4, then we look at the cases, right, to compute the matrix, to compute the distance profile of the x2, how we do is. So I have length of 4, I take x2, x3, x4, and x5 as the sliding window as the data set, right, to scan the entire data set. So I compare x2 to x5 with x5 to x8. Then I get the Euclidean distance of D52. Then I use x2 to x5, scan x6 and to x9. Then I got another distance D62. Then I'm using X2 to X5 to scan X7 to X10. Then I got the Euclidean distance of D7 2. Repeat the same thing to scan the X8 to X11. I got distance of D8 2. Then last, I compare the X2 to X5 with X9 to X12, and I get the Euclidean distance D9 2. To find the X2's distance profile, I need find the minimum distance among these 5 distance we just computed, and assume the minimum distance is D7, then my D2 is D72. Repeat the same process, right? We can compute we can compute the metric, this distance profile for all of the points. But there is one thing is here is like we have exclusion zones. Why we have exclusion zones? Because right, if I'm using X2 to X5 compare with X2 with X5, then I for sure, right, this distance is 0. So to don't get this duplicate things to disturbing our distance profile, in the matrix profile, they define the exclusion zones. And for the matrix profile, right, they can use to find multiphase and discourse. Multiphase basically is a regular pattern. So if you get to look at this, to look at the graph, if you get like a quite small distance, then basically it's right. You found something. You found another in this time series, right? You found in other places. You found the another time series which is quite close with you. So the Euclidean distance between you and the other is small. So you got this very low matrix profile values. And this is, we define this as the multiphase, regular happen pattern, which is regular happen pattern. And then if I got this like maximum value in matrix profile, it means, right, my current window is very different with the other window in my time series. So I'm outlier, so I'm a discord. Here is some like multiphase examples we found in our training data set. So you can see the regular happen pattern highlight in red. They look similar. And also, this is some typical example of discord. You can see it has very large distance, and also the shape is the shape of current, the highlighted data is quite different from others. So we using the nature of the matrix profile, we build our own detection model, which means since when we just present, right, the matrix profile is using the univariant. So for this outlier detection model, we firstly working on individual univariant time series. Then we merge and combine the detection results and give the then give a model which consider all time series. So the workflow is like this. Firstly, we look at the training data set without any attack. So using this training data set, we can find the window size. We're using 48 in current model. And then we do matrix profile, find the regular pattern. And then we got without any attack, what is my maximum distance we found for each time series. Then after we have all this prepared, we looking at the testing data set. So for the testing data set, firstly, we found a large number of discourse, and then using this discourse compare with the distance threshold we found in the training data set. So then we found we can filter a lot of the discourse. And then after that, we take this, we found this discourse, right? We take the corresponding raw data and match it back to the regular pattern we found in training data set. So if there are there are similar patterns, right? Then we can filter the regular pattern with reference of multi-fits from training data set. And meanwhile, right, for the discourse, right, filtered by distance threshold, we will do another comparison. If it's the discourse with max distance, then we will do another comparison. We will decompose it. We will decompose the raw signal and apply the matrix profile with the decomposite signals. If the discord or with max distance from the decomposite signal and the discord with max distance from the raw signal are in the same time, then we think this time, right, is has outliers as well. After the get the discord from two paths, we merge the results and then give the anomalies. Here we can have a look again to the workflow. And this is the way we are using for the decomposite of the signal. You can see, right, that is raw data. Then we found this, we're using the EMP. Then we found the IMF signals, and also the last one is a trend. And here is our final results for the detection. And we can see we cover the most attacks, but there's one limitation here. For these attacks, we are not able to fully cover it, and this will be the improvements we are going to focus later. So meanwhile, we do this autoencoder algorithms. Compression factor CF equal to 3 are used, and also the hidden layer we set is 3. And here is the results we're getting. Yeah, we can see for this autoencoder detection model, right? The most issue is the it get a lot of false alarms. Then go back to the matrix profile, since we're looking at the right. So it's not giving like much like false alarms in the irrelevant time. So the false alarm basically is from the relevant time, I would say. So then we can combine these two models So we combine the autoencoder with matrix profile model, right? We can get a better results. But still improvements can have in these missing periods. Meanwhile, to have a proper comparisons of current results of the results from matrix profile autoencoders, we implement the XG boosting, LED boosting, LED GBM, and CataBoost. This is the accuracy precisions we got. So then the plan for next week is we want to focus on picking up these missing detections highlighted in yellow, and then we can have a combined model with updated matrix profile and with updated matrix profile with autoencoder and with these three boosting approaches. Meanwhile, we will focus more on the writing the reports and also the PowerPoint slides in a more professional way. Yeah, that's it. There's some appendix on the paper who use the iTrust dataset.